Okay, I'm going to give the Pythagorean theorem a shot here. Let's see. We want to find the hypotenuse using the Pythagorean theorem. Well, to start with, DEF defines the function, and I'm going to call it Pythagorean. You could call it something different, hypotenuse. Any name really is fine that's indicative of what it actually does. And then the input should be two sides of the triangle. Now, if we're actually trying to find the hypotenuse, the other two sides would be the base and the height, because it must be a right triangle. If you put an A and B, that's fine too. In this case, it is understood with the Pythagorean theorem what A and B would be. So that's totally acceptable. Now put the colon and press return. So I'm going to take advantage of multiple lines of code to actually flesh out this theorem. So for instance, I know that the hypotenuse squared is equal to the base squared, which would be like a squared, say, plus the height squared, which is like b squared, okay? And note that I'm not like squaring the hypotenuse here because I'm assigning it to a variable that is called the hypotenuse squared, okay? But in the next line, then I get the actual hypotenuse by taking the square root of the hypotenuse squared. So that would be hyp squared to the 0.5 power. And then I want to return the hypotenuse, which I've abbreviated as hyp. Okay. Press Shift Enter to run the function. Okay, no errors. Now I want to call it to test it. Okay. You want to test your functions with examples that you know, meaning you know if the two sides are what and what, then you know what the hypotenuse is. Well, 3, 4, 5 is the ultimate Pythagorean triple. It's the smallest known one with the smallest hypotenuse. And if you put in 3 and 4 as your base and your height, your two sides, you should get 5 back as the hypotenuse. So here we go. Press Shift Enter, get 5.0. It feels good when you get them right. So there is a solution to the challenge of writing a function on the Pythagorean theorem.